Hello everyone and welcome to my YouTube channel. And today in this video we are going to see about containers, and then we are going to see why we should, what is the need of containers, why it is used. We are not going to go much into technical like the codes and all or the commands, but for sure in this video you will understand that what is the use of containers, what is Docker, and then difference between virtual machine and containers, like what is use of this containers. Okay, so not delaying much, we will start. Okay, and also I'll make sure that this video will be very easy for you all and very simple, in a very simple language. I'll try to make you understand these very interesting topics. Okay, so not delaying much, let's start with it. Okay, so before going to what exactly this container is, let's understand it by the use of a small story. Okay, so let's meet our character. Suppose there is a software developer. The name is suppose John. Okay, now this developer, he's a software developer, and another character is suppose he's Harry. Okay, okay, now he is software tester. Okay, now so this John. Okay, now John is very excited. John is very excited because he is fresher and he has just joined the company. Now he's very excited to work with the team and also to work on his the new project. Okay, so okay, and he's very talented. Okay, now what happens? John is working on a project, and on that project he's working with some packages, some frameworks. Like he's working, basically he's creating a project where different dependencies, different frameworks are being used. Okay, like we can say the version of Python is suppose 2.0. Okay, and then we have some different frameworks, suppose he's using Django, and then some different some different technology, some different tech stacks. Okay, now all those dependencies, all those libraries, whatever he's using, he's installing on his PC, and then he's working with that. Okay, so and finally after working with all those things, after he has created his project, he had like the project is working nicely on his it is working fine on his machine, and he's very excited. He's very excited that yeah, finally he has created his project, and now the next step that he needs to do is he have to submit it to the tester. Okay, the software tester. Okay, the name is Harry. This tester will test that whether this project is actually working or not. Okay, so John says, yeah, hi Harry, I have done my work, I have done my job, and now I'm submitting my project, just check it. Okay, so although as we know that on John's PC or machine it was working fine, the project was working very nicely, and he's very excited to submit it. Okay, now but what happens next? As soon as this Harry checks the project, it was not working. There's an error in the code. Okay, it is not working, it is showing some kind of error. What's that? Now there is a problem, but the problem is not in the code but with the dependencies. Now what's that exactly? No one is understanding. The tester, that is Harry, is saying that yeah, there is a problem in the code and I'm not able to run it. Okay, John is saying but it is working fine in my PC, like it is working, I can see it, it is working fine. Now what's the problem? Okay, there is a blame game that is going on between John and Harry, but the problem is not with the code but the dependencies. What happened exactly is that the version or the framework, or we can say all the dependencies that are being used in with John, like that are being used from John, is not there with the tester. Okay, it may be possible that the tester is using Python 3.0. Okay, or any other, like it may be that the OS he's working on is different. Okay, there may be so many reasons uh, because of which this code is not running. So the problem is with the dependencies, right? Now what we can do for solving this problem, okay, what we can do, okay. So there comes the role of this containerization. You can understand, as the name is, the same is the role, okay. This concept of containerization is nothing but it's simple. You can just understand that it is wrapping up all the, like, all the packages, all the framework, okay, in one, like, it is packing it, and then it is sending the code or the application with all those dependencies to the tester, and by which what is happening, the tester is directly receiving that container, okay. Like, just understand this. Now the John has, what he has done, he's creating a container, okay. He's creating the container of his project, okay. And then all the application code, the frameworks, the versions that he has used, like suppose if he is using Python 2.0, then with that version, the OS, okay, it is just transferring that container to the tester, okay. Now the tester will not have to worry about the dependency, or he don't have to install it manually, don't have to manually check that, yeah, which version John is using. He don't have to manually check it one by one, okay. He can just directly pull that container, or he can directly check with that container, and then he can run that code and check whether that code is running or not. It has make the it has make the work a lot more easier. Now you can understand how easy it is to use this container to remove this problem, okay. To just how easily this problem has been removed, okay. Now, so yeah, so I hope now this brief idea of containerization, what this container is being used for, is clear, okay. So in simple word, you can say that containers are, like, they are just, you can understand, it is a small software package that can run a particular application and its associated processes, okay. Basically it is wrapping all the like, you can say it is wrapping all the code, all the versions, or the, like, the applications, okay, application and associated process itself, and then it is sending it to the tester or whoever it is, like, it has to be sent for, okay. So that's the use of containers, okay. Now, yeah, so I hope this is clear. Now, what is the need of containers if we have virtual machine? Now, if you guys are familiar with virtual machines or hypervisors, then you must be knowing that the same work virtual machines does, right? The concept that we are, or the logic why we are using containers, the same thing is being done in with virtual machines. Then why we are not using virtual machines, and why we are going for containers? So let's see this. Containerized application, of why to use containers when we have this virtual machines, okay. As I've already said, I will not go much into detail about virtual machines or all those things, because in this video we are going to focus on containers and Docker, okay. So I'll try to quickly give you an idea about this virtual machines. It's also the same thing like containers, why we are using virtual machines, same thing like containers. Like, virtual machines provides an isolated environment for running its own OS, operating system, and application independently from the underlying host system, okay. What does that mean? It simply means that we can run multiple application, we can run different virtual machines on the same host, okay, on the same PC, and we can run different OS on the same host. Like, suppose if I'm having Windows, okay, if my host or my PC is Windows, okay, but still we can have this virtual machine which is having this OS of Linux or Mac OS, okay. So you can understand what is this virtual machine all about. It is used for isolating like creating an isolated environment for our application with its own OS. And that's the kick. Okay, that's the kick that makes it different from containerized application. In containers, what happens, the same purpose why we are using containers, the purpose is same, that is to isolate our application from the environment, to make it portable, to make it isolated or not dependent on the environment that is there, or not to depend on the host. The thing is, in containerized application, we are not creating like we if we are creating a container, then it's not that we have to uh, define the OS, or we have to run the specific OS. It runs on the host operating system only. Okay, the same operating system which the host is having, we are working on the same operating system. And that's the reason which makes it different from virtual machine, and it makes it more like it makes it different from the virtual machines. And that's the advantage of containers, that is basically when containers can be started much quicker than virtual machines. Why? Because we know that for virtual machines, see, the main disadvantages are running multiple virtual machines. Okay, on one physical machine, it can result in unstable performance. Why? Because you can understand it's how much like it is difficult to create, to run the different OS on the same host. Okay, to run it in the same time, it is like it will make the performance lose. Okay, it will uh, make it unstable. Okay, so and when if the infrastructure requirements are not met, it makes it difficult at that time. Virtual machines are less efficient and run slower than a full physical computer. Obviously, because we need to run the OS, we need to create, if we are running more than one virtual machine, it may cause it may lag the performance. Okay, so whereas in containers, what happens, it can be started much quicker than virtual machine. This is because container is using the underlying operating system and not starting its own whenever it launches. It's not like when we are launching or when we are deploying this app, it has to create its own OS, it has to run its own OS. It's not like that. It is using the host operating system. Okay, and that's why it makes it lightweight, or you can say it makes it quicker than virtual machines. And that's the quick difference between virtual machines and containerized applications. That's why don't get confused between these two concepts. And I would like to explain you this Docker concept by the help of this architecture, so that because I have already said that I won't be going much into technical code or commands. This video is totally for beginners, just to give you the brief idea about all those terminology or all those concepts that are used and in like this with Docker, or this concept of containers, images. So yeah, I'd like to just give you this quick idea about Docker. What is a Docker? So first of all, Docker is an open platform for developing, shipping and running applications. Okay, for running these containers, to pull it or to execute, to deploy it. Okay, we use this Docker. Okay, it is an open platform. Docker enables you to separate your application from your infrastructure, so you can deliver software quickly. Okay, you can, it makes it portable, it makes the software transfer or to deliver it, it makes it easier. Okay, so let's not go much into the theory part. Let's understand what is happening in the backend, how this Docker is working. Okay, so basically what happens, this Docker is working on this client server architecture. Now what's that? Okay, so basically what is happening, so this, there is someone called as client, you can say you are the client. Okay, and there is a server. Okay, Now client is requesting some command. It can be like, suppose you can understand it like, I want to pull an image, or I want to build an image, or I want to pull a container. Okay, I want to pull an image, suppose. Okay, so what is an image? I know you must be getting confused. For now, just understand that this is something like a container only, but for now there's a difference. I know that it's like, there's a, I will make you understand this, but for now just understand that, yeah, I want to pull image. Okay, so how it will be done? Okay, or I want to run, my software, my application. How can I do that with Docker? So basically there's, you can use the CLI, okay, command line interface, or you can use by the help of this remote API. What you can do, okay, you can just understand that you are writing a command. Suppose you are a client, you are writing any command, and for example, let's take it as you are writing docker run. Okay, and run, then any image name or something like that. Okay, this is my command. What happens? The client sends those command to the daemon. Okay, docker daemon. Okay, that is also known as docker okay, docker daemon. By the use of REST API, this command is going to daemon. Okay, the client and the daemon are interacting with the help of APIs. Okay, REST API. And then what happens? This daemon, okay, it checks the command. Okay, and if it is showing it, if it is asking to pull, like suppose if I'm writing docker pull an image name. Okay, pull an image name. Okay, so what will happen? Which carries them out. Okay, so what happens? This will check. Okay, it will check whether this image, it will then check, it will then pass that command to registry. Okay, and it will check in that registry. You can understand this registry as, it is the collection, it stores all the images. It can be, there is a docker hub, you can understand it like a collection of all the images that are already defined. Okay, that are already there. Okay, there's one docker hub, or even you can create your own local registry where you can create your image and you can store that there in the local registry. Okay, you can understand it's like a database where we have some built-in images that are there. So what happens? This daemon will pass that command to registry, and in that registry it will check in the local registry first. If that image is present in the local registry, then it will be sent. Else what will happen? That image, or you can see that image name, is searched in the Docker hub and it is pulled from there. Okay, so that's the basic architecture. What happens? By the help of Docker API, they are connecting. Okay, this client and daemon is getting connected, and likewise, what is happening? This client can run or build or pull the image. Okay, now what are image? Okay, so yeah, so let's just understand this. An image is a read only template. Okay, so what's that? Okay, not going much in technicals, just understand it like this. We all know what is a class, what is an object. Okay, you can understand it like this. Image is a read only template, or it's just a template kind of thing. Okay, which with instructions for creating a Docker container. Okay, like you can understand this image is like a layer. Okay, it is like a layer one by one on one. We are having some layers, and those are nothing but read only templates with instructions for creating this containers. By the help of this image, we are creating this container. Now in simple words, you can understand, image is a class. Okay, image is a class which is like a blueprint, you can understand, and we are creating an object from this class. Okay, we know that we know the concept of class and object. So from this class, from this template, we are creating our containers. Okay, we are creating our app. Okay, So I won't be going much into technical terms. That's why I'm just making you understand in this simple way, that understand it like this: it is read only template kind of documentation, or a prototype kind of thing. An image is a prototype kind of thing, which is a read only template by the help of which we can create containers. Okay, so yeah, so that's how it is working. That's how the basic architecture is. So basically this Docker uses client server architecture. Client communicates with daemon, okay, Docker daemon, with the help of REST APIs. Okay, this all the command that you write in this uh, command line interface or the terminal, that is getting going to the daemon. Okay, with the help of this REST API, it can be pull command, build command, or run command. So daemon accept the command and does the heavy lifting of building, running, and distributing your Docker containers. It can be to deploy or to run. Okay, so if a client is requesting to pull an image, suppose, okay, just like this. Okay, now what will happen then? First it will communicate with daemon. Daemon will search for the image in local image registry if it is present or not. Okay, it will go to registry, it will check in local registry if it is present. No, it is not. If not found, it will search for the default registry that is there, that is Docker Hub. Okay, you can manually define an any other registry if you have. Okay, so that's the basic architecture that we have for Docker. Okay, I hope you guys are now clear with this concept of what is this Docker, how it is happening in the backend. And as we have started from the scratch, I hope this basic idea of what is happening, what is the difference between containers and virtual machines, what is actually images, what is this registry daemon, and I hope you guys are now familiar with this concept. So let's just give your reviews in the comment sections, and thank you so much. uh, let's meet in our next video.